Okay, so this is my video for standard 2.1. I chose problem. Hold on, I forgot the number. I'll look. Problem 16, which deals with a spin 1 particle. So they give us that a spin 1 particle is prepared in this quantum state right here, and I've just gone ahead and represented it in matrix representation for use later. Then it asks us for the possible measurements of spin in the z direction and then to find the probability of each of those spins. So the possible measurements are 0, 1, and -1, because it's a spin 1 system. So it's now a 3-dimensional system instead of a 2-dimensional system like spin 1 half. And then the probabilities are just really easy because the quantum state is already written in respect to the z basis. We know that the probability of measuring the ith state is the modulus square of the ith component, and it's really easy to convince yourself of that. Basically, it comes through because just take 1 as an example. If we took the prob1, which represents like spin up, and multiplied it with this quantum state, this term would be 0 because the base is orthogonal, and this term would be 0 because the basis is orthogonal. And then we're just left with this, and then probability is modulus squared of an inner product. So then we just end up with 4 over 29. And then the other two work in exactly the same way. So then they ask us something a little trickier. They ask us what the possible measurements for Sx. So the spin in the x direction are, and then to compute the probabilities. So again, the 3 possible measurements are 0, 1, and -1, except in the x direction. So we want to be able to compute the probabilities. We're going to want to rewrite these in terms of the z basis. And then I wanted to re-represent them in matrix notation to make the inner product a little cleaner. So that's what I've done here. This is just straight out of the book. They give us these re-representations in the chapter. And then, therefore, probabilities are just taking the modulus squared of these inner products. So at this point, it's exactly like a dot product, pretty much. We just multiply and add component-wise. And then the only little wrinkle comes when we have to remember that we're not taking the magnitude, it's the modulus, because it's a complex number. And then we see that all our probabilities add up to 1, and we're good to go. So, and then finally they want us to calculate the expectation values. And then basically an expectation value is the mean value of all the measurements and the limit as the number of measurements goes to infinity. So essentially that amounts to summing the probabilities of each state over the state weighted by what their measurement outcome would be. And then that's what we get. So yeah, that's all I got for the standard.